All right, so let's look at this one. So whoops, y equal, so if I'm looking at x minus 3, and I'm going to factor the denominator out so I don't do too much in my head and make mistakes. So those x minus 3's cancel. So this is the same thing as saying looking at 1 over x plus 3, where x minus 3 cannot be 0, so that means x cannot equal 3. All right, so looking at this, this will be hyperbola with an asymptote at -3, right? -3, there's the asymptote. So it's the 1 over x graph, right? So the -3 is the asymptote here. And so when x doesn't equal 3, that's over here, right? And that's when there's the hole. So the hole comes from the canceling. All right, so let's look to see what the rest of this graph says. So this says when x is 3, put in a y value of 2, so just a flying dot up there. And when x is -3, put in a y value of 4, so a flying dot up here. So, is what it is. Very different kind of graph. All right, so you're going to get lots of situations where you're going to need to find the intersections points of two things, two graphs. So just graphing it just to see what it looks like. So I've got y equal x squared and then y equal x plus 6. So we can see that they intersect. So we find their intersection points by setting them equal to each other. So I know that's going to be x minus 3, x plus 2. So that gives me x is 3 and x is -2. So it could be that you need to find the xy points. So the y point would be, doesn't matter which one you put it into, would be 3, 9. And this one would be -2, 4. So these are the 2 points, the xy points, where they intersect. You might just need the x values, but just so you know. All right, x equal y squared. That's that sideways parabola. Know that. The graphing calculator is not going to give that to you. This here is a line. I'm going to take the time to rewrite it how I can see it graphed. So I'm going to solve for the y. So I move the 8 to the other side. If I divide through by the -2, I get a +4. All right, so it's a slope of -1/2 with a y-intercept of 4, so it looks something like that. All right, so I'm going to use the fact that it's x equal, so I'm going to set y squared equal to -2y plus 8, get it equal to 0. So I would have y plus 4, y minus 2. That would give me, this is out of this factor, so I get -4 and 2 for the y values. And again, if you needed to find the xy values, so if the y is 2, then the x would be 4. I'm just going to use this equation here. And so if the y is -4, the x would be 16. And if you think about the graph, that's what it looks like. All right, so y equal x cubed looks like this, and y equal x squared looks like this. Thinking, well, they cross at 0, but I don't see anything else happening. Well, we're going to be doing this, going to be investigating. Let's think about it. If I do y equal x squared again, kind of slowly here, and then I did y equal x cubed, kind of goes below that. Sorry, I should make my x-axis go like down like this. So this would be the point x equal 1. So if I set x cubed equal to x squared, and remember I talked about do not divide through by variables. Factor out. So if I factor out an x squared, I get x minus 1. So from this, I see x equals 0 and x equal 1. So they intersect here and they intersect here. And I can see that those would be the points 0, 0, and 1, 1. So just know sometimes you're going to have to investigate further to find out where they intersect. So let's finish this one. So 1 over x looks like this. 1 over x squared is very similar. So here and over here. So let's think about it, right? You might just want to just, put something like that and think, oh no, how does that work? So let's set them equal to each other. So if I set 1 over x equal to 1 over x squared, and how about if I multiply through by x squared? So I get x is equal to 1. So if I multiply, so what I did is I multiplied both sides by x squared. So I get x is equal to 1. So they do cross, so I just drew a random graph down there. So let's just go through this again. So here would be 1 over x is the blue one, 1 over x squared. So I know that they're going to intersect at 1. So this one is going to go, if I pick numbers larger than 1, it's going to be smaller, and then this one would be larger like this. So this is the point, x equal 1. So they intersect there at 1, and just make sure you're thinking about what the graphs would look like. So the intersection point would be 1, 1.